Welcome to the Redis cluster screencast. This screencast goal is to show you how Redis cluster works from the point of view of the end user, so we'll not discuss too much the internals of the system, but the feeling from the point of view of the system administrator and the programmer operating the cluster. So the first thing to do is to create a new cluster from scratch, and to do so we start with a few spare nodes. To create a Redis cluster node we need a Redis configuration enabling it, and as you can see we have a cluster enabled yes, and we specify also a configuration file name for the cluster that's called usually nodes.conf, and this configuration is not modified by the user, but it is a file where the cluster itself, every node of the cluster, writes the current cluster configuration, so that every time there is a change in the cluster configuration, the global cluster configuration, this file is updated by any instance, and when an instance is rebooted, the new configuration is always loaded. And this is the other important configuration parameter for Redis cluster, that's the no timeout. No timeout is the maximum time a node is not responding to our requests for us to consider the node to be unreachable. And of course 5 seconds is a very small no timeout, but it's very useful to have a small no timeout to show examples in a less boring way. And finally we enable the append only file, because this is the suggested configuration for nodes, because you can use other persistence with Redis cluster like RDB or no persistence at all, but append only is suggested because when there are reshardings, many keys can be moved from one node to the other node, while Redis cluster is able to cope with this kind of conditions where nodes are restarted with not exact configuration. It is better to have append only, so even if with a not too strict fsync policy, but at least when a key is moved across the cluster, we store that we deleted the key from one instance and the key materialized in the other instance. Okay, I have a few directories like this: C1, C2, and it's all the same. The only thing that changes is the port number, C3 and so forth. I have 5 of these. Should be enough for our examples. So let's start the first node. As you can see, Redis advertises that it is running in cluster mode, and I can run another one, and I have another one, but so far these are just 2 nodes, and they are not connected in any way. And indeed I can address a few requests to the first node, and it just knows about itself: myself, master, connected, no slots assigned at all. And the other one is the same, just there is the node ID that's different, and it's interesting to see that if I stop one node, Now we have the nodes.conf, and nodes.conf is exactly in the same format as cluster nodes output, and when I will restart this node again, it will have the same node ID because it's stored in the nodes configuration. Okay. In order to create a cluster, I need to use a tool that's called Redis trib. Redis trib is basically our command line utility that's used to check and configure Redis cluster. There are subcommands, and in this case I use create, specifying the address and port of all the nodes involved in the new cluster. Okay, and it says creating cluster, performing a hash slots allocation of 2 nodes, so the slots are distributed evenly across the nodes. To start, can I set the above configuration, and we accept. Okay. After the cluster is joined using the cluster meet command, the cluster is then checked, and indeed we have 2 masters. The M here, this M is for master and another master, and all nodes agree about slot configuration and all the slots are covered. So basically, if I ask again cluster nodes to one of the nodes, this time it knows about itself, but it knows also about the other node, and this time there are assigned slots in both nodes. So nothing prevents me from running commands. Set key 1 value 1. Okay, I got a redirection because that's how Redis cluster works, and the first node is asking me to send the query to another client, another node. Because Redis command line interface has support for cluster via the C switch, I can do it again with the switch, and this time the redirection will be automatic and the key will be set. I can set another key, and this key happens to be in the other node, and I got another redirect. Git get key 1, get key 2. So you can see we are able to talk with the cluster. If I ask something like that, we get the error, of course, because this is not supported by Redis cluster. Okay, so far so good, and but this is a too trivial client. I want a more interesting client, and for a more interesting client I can use Redis RB cluster. That's a wrapper on Redis RB with cluster support, and this is an example that shows how it is used. What I do basically is to create a Redis cluster object using an array of startup nodes that's just a subset of nodes, and at least one should be actually reachable. So this doesn't need to be all the nodes, and does not need to be all reachable nodes. And this is the maximum number of connections, parallel connections I want to take in the Redis cluster object. Usually it's good to have one persistent connection to every node, but sometimes if there are really a lot of cluster nodes and a lot of objects, it's better to lower this value because otherwise we will use all the file descriptors of the system. And then I have this very simple loop where I set foo1, foo2, foo3 and so forth, and if there is an error I see the error here, and there is a sleep in order to slow down the output, otherwise everything is very unreadable. Let's try our example. This is setting keys in our cluster, and of course I can just use a single startup node and everything works as expected. Okay, now we can ask to one of the nodes the keys stored, and in the other side, in the other node, we will have more keys. Nobody actually prevents us from writing data much faster, and actually we can keep it going so fast for a bit of time because this is useful to show the next thing to you. So let's try starting a new node. Okay, that's our third node, and now I can use again Redis trib to join this node to the cluster. As you can see, there is a command for this, and it's just Redis trib add node, the address of the new node C381 to the one existing node. Okay, now it's already joined, and I can ask the first node, cluster nodes, and as you can see, there is this new node. It's a master, but actually there is there are no hash slots assigned to this third node, so it will not be used at all currently. And while we set keys continuously to the cluster, we can ask Redis trib to reshard, to move a few keys from the first two nodes to the third node. And to reshard, I just point Redis trib to one random node, and it will load the configuration, check that always check that all the nodes agree about the slots configuration, and so forth. How many slots do you want to move? I want to move just 1000 slots. The receiving node is this one that has no slot at all. Please enter all the source node IDs. I can type all to say I want these 1000 slots to be taken from evenly from all the other nodes. Actually, it's not evenly, but it's proportionally to how many slots there are already assigned to every node. So if one node has 10 slots and another node has 100 slots, we will take just one from the 10 node slots and 10 from the 100 node slots. All okay. There is a very verbose move plan, and I accept this configuration, and it starts to move keys around. As you can see, while we move hash slots, everything here is working as expected, because resharding in Redis cluster is completely hot. It runs while the system is running. Okay, we should be about to finish. Okay, now instead of the reshard command, I use the check command to check the new configuration, and as you can see now the third node has 100 slots assigned, and I can ask besides there are 32,000 keys in this node. The other nodes have more keys because they have more hash slots. Okay, now we have this client running. Edit again the example in order to slow it down to show you something. That's what happens if we stop one node. I stopped the first node and we start to have errors, and the cluster in short time realizes it's not possible to go forward and enters in an error state. Okay, cluster state changed fail, and this one too, and I can ask to one node cluster info, and the problem is the cluster state is fail because out of all the slots there are a subset of slots that are in the fail state, and so the cluster can accept new queries, and every request gets this error. But because we had no replicas for our first node, there is nothing that can recover this condition. I can just restart again my node, and once I restart it again, everything starts working again because clear fail state for node blah blah blah, because it's reachable again and nobody is serving its slots after some time. So basically the cluster, if the cluster realizes that it is the failover didn't happen for some reason, it will allow the old master to rejoin the cluster again, because this way we can continue to operate. Now let's try to add some replica. To start, we need a new node and yet another one, C5. Okay, I have these two spare nodes, and using Redis trib I can add the new nodes to the existing cluster, first one and the second one. Okay, here we got an error just because the check is performed without any pause. Now everything is okay. So these errors are completely harmless. It's the way that the cluster joins, that sometimes we already know a node and it will try to ping our node, our new node, with an handshake packet, but just we already know a node. This error currently is in warning level for an error in the code, and should be like debugging or something like that. Now that I have two new nodes, let's conduct the first one and ask cluster nodes. Okay, this is myself, and this is the first node 6379, and I can say the new node cluster replicate this node. Starting from now, this node is a replica of the first node, and I will do the same with the C5 node. Okay, and if you see the logs, both nodes started the replication process, the first one and the second one as well. Now what's interesting is that because we don't replicate by address but by node ID, I can stop the first node, the fourth node, start it again, and it will automatically know what node to conduct to perform the replication. And the same for this one, of course. Okay, now we have finally two replicas for our first node. That's this one. So we have our client, our example client, happily running, and this time we can finally stop our first node, and at first we will see errors, but after some time the cluster will agree about the failover, and the cluster is working again, as you can see. Let's see what happened. Okay, here it's the interesting part. Master's quorum reached, failing over my failing master, discarding a previous case, and so forth. Okay, and the cluster state changed to OK again. This works by quorum, but the failure detection and the authorization a slave needs to turn into a master of a failing master needs to be authorized by the majority of the master nodes in the cluster. As you can see, we had two different replicas for the node that I stopped by Ctrl+C, and so the other node as well reconfigured itself, and we can see it here. Okay, one of the slaves failed over my master, so I'm reconfiguring myself as a replica of the new master. And another interesting thing is that if I start the old node again, the old master C1, it will immediately detect that one of its slaves was promoted to master, and it will turn itself into a replica of the new master. And the result is that everything is working as expected from the point of view of the client. Okay, that's it. I hope that this small presentation somewhat helped you to understand what Redis cluster is going to be from the point of view of the end user, and what kind of problems it can solve. Bye bye.